Hello friends, now that we have learned the basic concepts of DEA, today we will be learning how to solve a DEA problem using Microsoft Excel. DEA is Data Envelopment Analysis. So for the purpose we will be making use of a plugin or an extension or whatever we may call, because it is not exactly something that we import into Excel, but it works. It in fact calls the Excel. Here we have this plugin DEA. I would recommend that you download it from the link given in the description and keep it as a RAR file also, because when you extract it, it will create a folder, and here is our plugin that we'll be using. So when we are working on a question, it might so happen that we might save something to this plugin. In that case, what happens is that this plugin gets corrupt and you might not be able to use it again. So it is better that you download this RAR file and keep it on your workspace, and whenever you need or whenever you feel that you have corrupted the plugin, you can again extract it to DEA, replace the original file. Now once you have this plugin, we'll call it when we need it. For now what we'll do is, we have been using an example of postage system. In that we took post and courier. These were the two services that we were taking to compare. Now here we see that we have created an Excel file that contains these two departments, post and courier, which are servicing our postage requirements. Now the file should be in particular format. First column should always contain your departments being compared. It could be A, B, C, D, it could be bank 1, bank 2, bank 3, it could be a hospital 1, hospital 2, hospital 3, or whatever are the departments that you are comparing. So first column we have your departments, then in successive columns you will be having your outputs and inputs. For all the outputs you need to prefix this thing in particular. What is this? This is bracket O and bracket. Now this bracket O and bracket tells the DEA module that whatever is contained in this column is an output. Then you have your second output, again you should have O, third output again you should have O, and then you have your inputs. So inputs you can have bracket and I. So this is the basic format in which we will be preparing our Excel file, which will be importing into the DEA module. Now we have been taking the example of post and courier, as we saw in our previous videos where we were understanding the basic concept of DEA. So post and courier, we were taking three output parameters on which we were comparing. First was number of deliveries that they can make. Second one was the geographical reach that each one of these has, and third one was the speed at which they are delivering us the postage or the material, whatever we are sending. And for this we had only one criteria of input, that was manpower. This is what we have been using in our earlier discussions. Today we will try to solve this using a DEA module, and then we will try to analyze what are the various results that we can get as a result of that DEA solution. Now this is our book which we have called DEA PC. PC telling us post and courier. So this is DEA PC. Now we'll close it. We'll save if we have made any changes. Now you can recall that these were the values that we have been using. For post there were number of deliveries 8, geographical reach 12, speed 3 and manpower 10. For courier it becomes 12, 8, 5 and 10 respectively. So we'll close this file, and now we'll call the DEA. Double clicking this DEA calls it, Here we have our DEA solver. Now, when we look at this DEA solver, we click here to start. It is the first step. The solver proceeds as follows: selection of DEA model, selection of data file in Excel sheet, selection of a workbook for saving results, and DEA computation. So what we'll be doing is, we'll be selecting a model. There are n number of models. We in particular are studying CCR model, and in CCR also we'll be talking of the output. So you can have CCR input, CCR output, CCRI, CCRO, and then there are n number of models. Whichever you are studying or whichever you need to discuss upon, you can make use of that model. So first is selecting your model. Second is selecting the file which we had saved right now, DEA. We called it PC, postage and courier. So that is our main file which contains our data set. Then we'll be selecting a workbook for saving the results. So first step is select your model, second step is select your data, and third step is select a file where you wish to save your results. And fourth step is go for DEA computation. So let us click OK. First thing is select your model. While selecting our model, we are taking CCR, and in CCR also we are taking CCRO, CCR output model. Okay. The next step is selecting your dataset file. Okay. My dataset file is lying on desktop. On desktop it is DEA PC. Let us open this file. Now it is asking if you have multiple sheets, then it will ask, is this the sheet that you are talking of, or it is something else. If it is another sheet, you could go for another sheet, but we have only one sheet in our file, and so we'll pick this sheet and we'll click OK. Next we need to tell the module where do we wish to save the results. Let us click OK. We'll save the results in DEA PC. Let us call it solution. DEA PC solution. Save. Now everything has been done. We have selected the model, we have selected the data set, we have selected a file to store the results. Now let us go ahead and hit run. You see, everything has been calculated. We have graph 1, graph 2, rank, weighted data, weight, score, summary, etc. Now we'll exit this model and we'll go through all these sheets. What are all these sheets? Now sheet 1 contains the data that we had provided, the data that we had in original file. The sheet 1 simply contains that data. Then you have a summary. This summary is very basic summary. If you go through it, how many number of inputs we had? We had number of inputs is equal to 1. What was that input? It was manpower. How many number of outputs you were having? We were having 3 outputs. The 3 outputs were number of deliveries that they can make, geographical reach and speed. Then here we have some statistics on the input output data. Maximum was 10 and 12. We'll bring this data over here for an analysis so that we could compare it. Now, what was the maximum manpower? Maximum manpower was 10. Maximum manpower. What was the minimum manpower in this? It was again 10. Then what were the number of deliveries? Maximum and minimum. Maximum deliveries were 12. Minimum deliveries were 8. What were maximum and minimum geographical reaches possible? 12 and 8. 12 and 8. What was the speed? 3 and 5. Maximum speed was 5. Minimum was 3. So this is maximum and minimum. Then of these maximum and minimum, it has tried to find out average and standard deviations. Fine. And then you have number of efficient DMUs, decision making units. Now because we are taking a case where we have only 2 DMUs, in earlier videos you would have seen that if you have only 2 DMUs, they both are bound to be efficient. The inefficiency only creeps in when there are more than 2 DMUs. Then it is possible for you to have an efficiency frontier consisting of only 2 DMUs, and the third one is lying outside of that frontier. Third one could lie on that frontier also, but there is a possibility that the third one may lie outside the frontier. But when you have only 2 DMUs, then they both will lie on the efficiency frontier, and because they both lie on the efficiency frontier, so we are getting number of efficient units 2, number of inefficient units, decision making units are 0. So this is our first sheet. And then we go for scores. Scores are post and career, both are getting first rank, both are getting a score of 1. Now because this was a very small case, we were having only 2 DMUs, so we might not be able to learn a lot about the DEAs, which we'll learn with next example. For now, our both units are efficient, so we are getting a scores of 1, 1. What about weights? Now weights, these are very small weights, so we cannot understand them. Let us format these cells and let us convert them into, let's say, 4 decimal places. Now let us talk of weights. So here we see that for post, we have seen that postage was not doing so well in case of third output. What was our third output? Once again, let us carry this with us so that we could compare. Now for third output, that is speed. For speed, post was not doing so well. So what is recommended in weights? It is recommended that post should concentrate on number of deliveries. It should put its most of the emphasis in number of deliveries that it can make, and it should concentrate the remaining of its power in the geographical reach as far as the weights are concerned. And what about the weights of courier? We see that courier is doing better in the speed area. Now see, we have checked in previous videos also, if we have 2 departments, post and courier, if we see that post is doing not so well in cases of speed, but courier can do better in speeds, so we'll focus on courier doing better on speed frontier, while post doing better on the other frontiers where courier is not doing so well or doing equally good, because courier can definitely do better in this speed frontier. So this is why we are seeing in the weights that the most of the weightage courier should be giving is to the speed, and most of the weightage that post should be giving is to number of deliveries and geographical reach, because courier can definitely do better than post in speed frontier. If we see about the other 2 outputs, that is number of deliveries and geographical reach, they are mixed, 12, 8, 8, 12. So we are indecisive, but we are definitely decisive about speed. So we are giving better weights to courier in speed. And as far as inputs are concerned, both are having an input of 10, 10. Other 2 outputs are literally similar, 8, 12, 12, 8. So they are literally the same. What about weighted data? Now if we talk of weighted data, you can see out of the 100%, 40% concentration should be on post and 60% concentration should be on 40% concentration of post should be on number of deliveries and 60% should be on geographical reach. While as for courier, 100% effort should be on optimizing the speed, because they do very well on speed frontier. What about scores and ranks? They are 1, 1. So weighted data is literally a summation of these 2 sheets of weight and score. So we had sheet 1, we had summary, which had some statistical data, averages, totals, maximums, etc. Then we had scores, then we had weights and weighted data, and this page literally has score, rank and everything summed up. So we have score, weight, rank and weighted data, everything. Ranks 1, 1, 1, 1, 1, 1 we have, these ranks are given over here, and then weights, these weights are given here, scores are given. So these 3 sheets are literally summarized in this. So we have first sheet with our data, then we have a summary of statistical parameters, averages, and standard deviations, etc., maximum, minimums, ranges. So first sheet, second sheet, and then these 3 sheets being summarized into the weighted data. Then next 2 sheets that we have are graphs. These 2, if we see, these both are literally similar because we are taking a very small example of only 2 inputs. This will see a difference coming in our next example, where we will increase the number of companies or decision making units that we are having. Right now we are having only 2 decision making units, so we cannot compare much, and that too both decision making units are doing very well. So we cannot compare this graph 1 and 2, so we will be checking graph 1 and 2 in our next video or in the next example rather. These two are exactly same. The first graph shows them in exactly the same order, the decision making units in the same order as we have taken. If it is ABCD, it will be showing ABCD, while the other graph will be showing them in descending or ascending order. So this is the only difference in the representation. Data is essentially the same. And what is this data? This data is coming from this sheet. We'll see this in next. So graph 1 and 2 we are leaving for now. We'll understand with the next example. Then there are projections and slacks, last 2 sheets. What are these projections? Projections are, this again is a repetition of what we have seen in past, scores and ranks. Now let us come here. Projections are that you are using a manpower of 10, you should use a manpower of 10. The data is 10 and projection is also 10. So what is the difference? There is not much difference. It is good what you are doing. What about courier? 10 and 10, no difference. We have seen that their scores and ranks are very good. These parameters will become more understandable in the next example. For now we are taking a very small example so that we can understand these basic columns. What are these sheets? What are the basic columns? What about number of deliveries? You are making 8 deliveries. Good, you should carry with 8. 12, projection is 12, speed 3 and 3. What about these? 12, 12, 8, 8, literally same. Fine. So here we can see this data being repeated with average, maximum and minimum, what we saw in the summary page. We had our data, we had maximums, minimums, same is happening over here. You have your data, and then from this data, what is the maximum that we should be targeting, what is the maximum deliveries that we can make, what are the maximum geographical reach we can hit. So this is maximum and minimum coming from the above data. Fine. And then last one is slack. Now in this case we are getting literally 0 slacks. First of all, these are the slacks and these are the average, maximum, minimum and standard deviation of the slacks that we could have had in the above table, this table. So what are the slacks? Slacks are the resources that will go unutilized. Now if you remember the previous videos, I'll try to put it up in some way in this video also if I could, but if you remember the previous videos, we could see that if we have a efficiency frontier, we have 2 points efficiency frontier, we have a efficiency frontier like this and one point is lying down. So if we see that we had this efficiency frontier, I'll try to put it up in this video also. If I could not, then you could check the other videos. So all the DMUs that are on efficiency frontier and all the DMUs who are left below that efficiency frontier, we tried to project those inefficient DMUs to the efficiency frontier, and that projection is an imaginary DMU, which if this DMU does well, it will reach that efficiency frontier. We have our efficiency frontier, we have our inefficient DMU. If we take from origin and draw a line, this line will hit this efficiency frontier that is going here somewhere. This point where this line and efficiency frontier are hitting, this becomes our projected virtual DMU. Now if you are working with that virtual DMU, then there might be some slacks. If you are working with my given priorities and weights, then you might be doing well in some areas, not doing so well in other areas, and some resources might go unutilized. The slacks will show us those resources that go unutilized. So this was it. How do we interpret this? How do we use the DEA and how do we interpret this? Now let us quickly jump to our, now they are saying DEA, save changes to DEA PC solution. Yes, definitely we can save. Want to save changes to DEA XLSM? No, we do not wish. Even if you save incorrectly, you should not save these changes. And if I say, let's say I go ahead and save these changes. So now what I have done is, probably I have corrupted this module. Let me try and run it. Here we see. Now when we go to selection of sheet, it is throwing me an error. Why is it throwing me an error? Because I saved the DEA XLSM. I told you we should not have saved it, but we have saved, so probably we have corrupt that file. Now what do? We are stuck? No, we are not stuck, because we have the original DEA-RAR. We'll once again extract it to DEA. Now look at this. Would you like to replace the existing file of size 1001.844? The actual file, the original DEA is 1560013, but because I have saved, because there are some modifications, this size has changed, and this is the corruption that is not letting me move ahead. So yes, I'll go ahead and replace it. Now that I have replaced it, I'll change the name of this file. It was post and parcel. Let us try. Now let us call this DEA once again. We've called our DEA. Click here to start. First we'll select our model. As we know, CCR output we are using. We have selected CCR. Now we need to go and pick our data set. This time we'll be picking a different data set. Data set of 4 DMUs. Now we need to select sheet. We have only one sheet, so we need not select. If you are having multiple sheets, sheet 1, sheet 2, sheet 3, like if you are working on 10 different questions, you might be having different sheets. So you can pick your sheet. In our case, we are picking only one sheet, so we will continue with that one. Now we need to select the book where we wish to save the results. Okay, we'll save our results to DEA PCSP solution. Fine. Hit run and it will solve it for us. We have the solutions, you can see here. Now we'll exit this module. Let us jump to sheet 1. Sheet 1 has our original data. You can see. Now what I did was, sorry, I didn't show you the original data. I prepared a different sheet, DEA PCSP. So this sheet had 2 more departments. Earlier we were having only post and courier. Now I created 2 more departments, speed post and registered post. Now if we talk of speed post, we are having number of deliveries 10, which is between post and courier. We are having geographical reach 10, which is again between post and courier. Speed, we have seen in our earlier discussions, earlier videos, that the lower the speed, it is better. But we are talking of outputs. So DEA understands that output should be maximum. So how do we do about this? We take the speed, the maximum speed possible, and subtract, invert everything. So when we have inverted, the slowest component, the slowest speed actually gets only 3. Courier gets 5 because it is doing very well, very fast. Speed post is again between post and courier. And manpower, we are engaging more manpower in. Now you can see that these 2 rows are exactly the same. Post and courier are exactly the same that we had used in previous example. But now we have 2 more departments and we have changed shuffled the values a little bit. We have changed the manpower, we have changed the speeds and everything. Last department decision making unit that I have added is registered post, who is making very few number of deliveries, but then it is also engaging very small manpower also. As far as speed is concerned, it is very slow. If you compare it to post, it is far slow. Probably it is being used for larger parcels. They are not being carried through maybe air, they are being carried through train, road, rail, whatever it is. The speed is very slow. Geographical reach, they have very high geographical reach. They are even moving into villages because parcels, packages could be sent anywhere. So this is the data set that we had created for this example. Sorry. So we'll close this data set. This is our DEA solution. So first sheet has our data set as we have seen. Then there is a summary. What is the summary? Summary is maximum, minimum and averages of these. It becomes very big. Once again, to understand this, we'll copy this data so that we could compare it. We copy it to 2 places. One is here and one is on this page. Now summary. What is this maximum manpower? Maximum manpower we can see is 12. Minimum manpower we can see is 4. So maximum is 4 and 12. If you see average, it is average of these 10, 20, 32, 36, 36 divided by 4, 9. These are the values. Then you have your speed 354.5. Here you have your speed. So maximum, minimum, average and standard deviations are over here. Then number of efficient DMUs 2, number of inefficient DMUs again 2. Now if we open up the previous solution also, let us open, and then we'll compare these two. So here you can see we have DEA-PC solution, the previous one, this is the present one. Now in present one we are having a look at our summaries. So let me open the summary one. Now in this case, number of efficient units were 2 and none were inefficient. I told you that if you have only 2 efficient DMUs, decision making units, then they both will lie on the efficiency frontier, because 2 are at least needed to build a efficiency frontier. Third one could go anywhere. It could lie on an efficiency frontier or it could be an inefficient DMU. Here we see from 4 of our DMUs, 2 are efficient and 2 are inefficient. What about the scores? We'll move to this sheet because we have everything consolidated in this. We have seen that score, weight, rank, everything is in this sheet. Now, what about the ranks? Registered post and courier are getting the best ranks. Courier is doing well, no issues, because courier has a very high speed. We see that it has the best speed. Now, what is the reason that registered post is doing so well that it has been termed as first rank? Why is it so that registered post is lying on our efficiency frontier? Probably the reason might be the manpower. It is using very less of manpower and it has very huge geographical reach. Yes, it is doing very poorly on the frontiers of number of deliveries and geographical reach, number of deliveries and speed. So it is doing, registered post is doing very poorly on number of deliveries and speed. But when we have a look at geographical reach and manpower, it is using very less of an input and it is giving best of the outputs in terms of geographical reach. Probably this is the reason why what has pushed registered post into rank 1. And of course courier is doing very well because courier is doing very well on speed frontier. As compared to everybody else, it is having the best speed. Others are not dominating in either. If we have a number of deliveries, courier is dominating. If we have geographical reach, registered post is dominating. If we have speed, courier is dominating. If we have manpower, registered post is dominating. So these two have gone on to become rank 1s. The other ones have fallen bit behind. What are the ranks for other? Now 1 and 2 gone. Third rank is post and fourth rank is speed post. And what are their scores? Scores are by and large their performances attributed to what all are they doing as a result of the weights that have been assigned. What are the weights? These are the weights that we have been assigned. If we have a look over here for post, post seems to be doing, first let us pick courier. What about courier? Courier has first rank, it has a score of 1. All its efforts should be put into speed because that is the best it is conquering. There are other areas where other people might be doing better, but as far as speed is concerned, there is no match for courier. We saw this with the earlier example also. If we go to weighted data, for courier, all its weight was given to speed. For post, the weightage was given to number of deliveries and geographical reach. 40% to number of deliveries and 60% to geographical reach. Now in this second case, let us see what has happened. Here is where it starts getting tricky. We'll carry it over here so that we can see it. Now, if we talk of post, which was having weights of 40% and 60%. What are the weights now? Number of deliveries. We are asking post to not concentrate on number of deliveries. We are asking post to concentrate on geographical reach, which is very good in case of post. Geographical reach is 12. It is second in the complete DMUs. And we are also asking it to concentrate on speed, which is okay, which is not as bad as registered post. So as far as post is concerned, we are asking it to concentrate on two of the outputs, that is geographical reach and speed. It does not mean that we are not concentrating on number of deliveries, which we will see in the sheets to come. But it should put an emphasis on the two outputs of geographical reach and speed. So we have talked about courier, which was first time. We have talked about post. Then next, let us talk of registered post. What is happening to registered post? Registered post should put all its effort on number of deliveries and geographical reach, which makes sense, because as far as speed is concerned, what best can registered post achieve? It is moving at a speed of 0.5. Now, how much can it improve to come at par with post courier or speed post? It has to improve 6 times to just match post. And when it matches post, it is not doing exceptionally well. It is only coming to the lowest. Just after that, it itself is working on 0.5, and if it improves its 6 times, if it multiplies its efficiency or speed to 6, then it will reach only to post, which is in fact at the lowest level. So we are coming to a conclusion that as far as registered post is concerned, it should not put so much emphasis on speed, because there is not much scope of improvement. While if we talk of number of deliveries and geographical reach, we are giving sufficient importance to these two. In fact, we are literally saying that it should put 80% of its emphasis on number of deliveries and 20% on geographical reach. Geographical reach, it is already having all very good. It is doing very well. So it should concentrate on number of deliveries, because it is 4. If it puts little more concentration on it, it could almost be of the order of post. Now compare speed. If it were improving it 6 times, it would only reach post, which was the lowest. But if it improves its delivery system just by 3 times, it will be the best in delivery. 6 times, 3 times. This is why we are putting a high weight for registered post on number of deliveries, and little bit weight on geographical reach also, because it is doing well. And what about speed post? Speed post, we see the number of deliveries are 10, geographical reach is 10, and speed is 4. So if we have a look from here, it is between post and courier. If we have a look at geographical reach, again it is between post and courier. If we have a look at speed, again it is between speed and post and courier. So the weights given here shape up like this. 25% of the effort of speed post should be on improving its speed, because it is doing very well in speed 4. If it improves a little bit more, maybe it could catch up with courier. And if it catches up with courier, then it will be dominating courier in 2 areas. Geographical reach, as it is better than courier. Speed, as it is better than post. And if a little bit of improvement will take it at par with courier. So if it works on its speed and geographical reach already it is above courier. Slight improvement, as we are suggesting, 25% of efficiency. Slight improvement in speed post will take it better than post also. Geographical reach, slight improvement in geographical reach will take speed post above post. Slight improvement in speed of speed post will take it above courier. Slight improvement will take it above 5. Slight improvement here will take it above 12. So it will in fact come to, it might in fact come to first. So that's why we are concentrating on these 2 points. Fine. And what about the input? weights, input weights, we have given a weight of 1.33, 1.36 to speed post, and for courier and registered post they are 1 each. So this was a summary of these 3 sheets: score, weight, rank. They have been summarized into weighted data. Next, graph 1 and graph 2. Graph 1 and graph 2. They seemed similar in our previous example of post and courier, but now with post, courier, speed post and parcels or registered posts, here we can see. Here is what was our sequence? Our sequence was post, courier, speed post, registered post. Post, courier, speed post and registered post. So this is the sequence in which we had put the data in decision making units in our data sets. If we see, post is at 0.75, speed post is at 0.73. Again, post is at 0.75, speed post is at 0.73. So it is essentially the same graph. It has been sorted in our order, the order which we gave to DMUs. This graph has been sorted in ascending or descending, as you may say. The lowest performing DMUs are DMU scores are here, the highest performing DMU scores are here. So this was graph 1 and graph 2. What about projections? Now here we see our projection table is bit more detailed. Last time it was very straightforward: 8, 8, 12, 12, 12, 12, 8, 8, 3, 3, 5, 5. There was not much scope of improvement. Why was there not much scope of improvement? Because those 2 DMUs were already on efficiency frontier. So what better can they do? DEA takes you to the efficiency frontier, the best that is happening. You were already doing the best. This time there is a scope for improvement for everybody. If we have a look at courier and registered post. Courier and registered post, we are literally happy with them. As far as courier is concerned, we have no issues at all. We have given 100% to speed, 100% score it is getting, no weightage has been given to deliveries and graphical reach. So if we have a look at projections of courier, no changes. They are getting 100% marks. We do not wish to change them. 12, 12, 8, 8, 5, 5. What about registered post? Their score is 1. We do not wish to change it. Why do not we wish to change them? Because they are already on efficiency frontier. The other 2 DMUs, courier and post and speed post, they are not on efficiency frontier. So for them we have some suggestions. What are those suggestions? You are working at 8, your projection is 11.46. What is this projection? Once again I'll try to put up some explanation of this in this video also. We'll see how I can manage it. Now projection is, you are working on 8, we need to push you to 11.46. You are working on 12, we need to push you to 15.95. And what is the difference? There will be a 32% difference. In this case, where 3.5 something you are improving, on a scale of 8, you are improving 3.46 on a scale of 8. So that is a difference of 43%. You can improve 43%. Here you can improve, there is a scope of improvement of 33%. Here there is a scope of improvement of 33%. So for post, we have our recommendations. What are these recommendations? We are trying to pull this line. We have a line, we have our DMU, or what I'll do is, I'll manage it some way. We have our line, we have our efficiency frontier, and we are trying to project it to a virtual DMU, which is on our efficiency frontier. If you try to project post to that efficiency frontier, these are the number of deliveries, geographical reach and speeds that it should target for. If I have a look at speed post, you are working at 10, we expect you to do at 14. You are working at 10, we expect you to do at 13.7. You are working at 4, we expect you to do at 5.5. If you push yourself to those levels, you will be on that efficiency frontier. So this is our projection sheet. This again is a summary, maximum minimum. What is the maximum in data? 12 and 4, maximum minimum is 12, 4. We have 12, 4, then there are averages, standard deviation from that data, simple standard deviations and averages. Maximum is 14.1, minimum is 4. Maximum is 14.1, minimum is 4. Then you have maximum change is 43, minimum change is 0, same. Maximum is 15, minimum is 8, 15 and 8. Then here you have a maximum of 15 and 8, again 15 and 8, 15.9 and 8, we have here 15.9 and 8, and so on. You can see this table. And then what about slacks? I'll bring the original table also here. What I'll do is I'll put up the DEA solver and these 4 Excel sheets also to my Google Drive and put a link in the description. So you can download these Excel files also to make an analysis at your own level. Now I'll copy this and take it over there to our Slack page so that we could try to read it in. Here we have. Now, and we'll also bring projections. Let us have a look into it. Where is the weighted data? We have spoiled it a bit. It's getting big. Let us make this column a bit smaller. Yes, now we can have it on one screen. Still not working. Just one more. Or rather, what I'll do is I'll reduce the size. Yes, now we have everything on one page. Now have a look at post. All its effort is going into geographical reach and speed. Now if all your effort is going into geographical reach and speed, then you're doing very well in geographical reach and speed. And this, that is number of deliveries, there is some slack. Some capacity that you could have reached remains unutilized. You could have done this, but this is going idle. Why is it going idle? Because you have concentrated on other 2 things like geographical speed and geographical reach and speed. Because you have put all your concentration on those 2 outputs, definitely there will be some loss in number of deliveries. Then as far as courier is concerned and registered post is concerned, they are already on efficiency frontier, they have no slacks at all. When you are working optimally, what are you wasting? You are wasting nothing. You are you are utilizing your resources to the best level. You are not leaving anything go wasted. So courier and registered post are no slacks at all. Courier, no slack. Registered post, no slacks. As far as post is concerned, because all your effort is going on geographical spread and speed, and you are not concentrating so much on number of deliveries, so there is some slack. All your effort was here, so you optimized it. Nothing is left behind that you could have done. Nothing that you could have achieved is remaining unachieved. But then, because your concentration was not on the number of deliveries, something is remaining. And same happens to speed post. Speed post also, we had asked speed post to work on geographical reach and speed and not care so much about number of deliveries. So some portion of number of deliveries is going wasted. So this is how we saw DEA on Excel. We have already worked out some videos understanding what exactly DEA is, data envelopment analysis is. We tried various combination, 1 input, 1 output, 1 input, 2 outputs, 2 inputs, 1 output. And here we saw how DEA works with Excel and how to read into the information. These are the weights that we are giving. Now what are these weights if we try to read into them? These weights are that all these 4 businesses decision making units belong to me. All these decision making units belong to me. Now what I wish is that if some units are better at something, let them perform that task, and if some unit is not so good at some other thing, then let us concentrate on some other area. Like, remember the example that we used. If you have two childs, one is very good at car driving, another one is very good at bikes. Now this car driving child A can also drive bikes, but he cannot drive bikes as good as in a race. But car, he is so good that he can drive in a derby, he can drive a Formula 1 car, he is very good with cars, four-wheelers. The other one, B, is very good with bikes, he can drive bikes in races. But as far as cars are concerned, okay, he might test drive a car, but he is not good at races. So what will we tell those two childs? What will we tell to those two sports person? We'll tell them, the one who is good at cars, concentrate on cars. You can win matches, you can win races, you can win medals in cars. Your bike section is not so good, so you better work on your cars. The other one, you are better on bikes. As far as test driving is concerned, okay, you can do, but concentrate on your driving skills in motorbikes. So what are we doing? We have two decision making units, A and B. One is good at cars, can drive bikes. One is good at bikes, can drive cars, but we are giving them different approaches. To one, we are saying, both are my children. To one, I am saying, go ahead and drive cars. To other one, I am saying, go ahead and drive bikes. Now by doing so, they both will win their races, and ultimately my profits, my outputs are optimized or maximized. So this is what I am doing with these DMUs also. I am identifying their strengths and weaknesses, and then asking them to work accordingly, to give importance to certain outputs more, to other outputs not so much. Fine. And now in this DEA series, I plan to make one more last video in which we'll be taking two inputs and let's say three outputs, and then we'll try to analyze into this area also, because right now we were having only one input, so we are not so much clear what are these numbers. So with another example of two inputs and three outputs, we'll try to see what is happening over here. Fine. Hopefully this clears some doubts on DEA, how to work on DEA using Excel, Microsoft Excel. And once again, I'll upload these Excel sheets and the DEA module onto Google Drive and put the links in the description. If you have any queries, questions, put them up in the comments box. I'll try to address them as and when I can. I'll try to address them at earliest. You can leave them in comments. So thanks for watching. Bye bye. Take care.